Hey, it's an interface, and we are putting a main method, public static void main. Fine, so this works. It wasn't there. Fine. So we have static methods in interfaces from Java 8. And that's one thing. So changes in the interface.
Previously, all methods are
Yeah, you only had abstract methods only. Yeah, and now we can have static methods. That's one, plus another method, because by default the methods are abstract. In interface, by default methods are abstract. So it also allows you to have implementation. Static anyway has nothing to do with the object. Fine. So we can have implementations on the objects of this type. Okay. So we have default methods. Change. Yeah. Now the reasons it's like this. Fine. Through various versions. Fine. Java has always maintained backward compatibility. Now see, what was the problem with this to maintain backward compatibility and the restriction that we will only have abstract methods in a interface. Now just think, we have this interface called list also. List is also an interface. And then later this was done in Java 2. This interface was defined in Java 2. Now if someone thought, oh, we should have a method called sort also. It was forgotten that time. Fine. But the new version of Java, can it give a new, add another abstract method in that interface? Can we add a new abstract method in an interface from the previous version in the new version? Because it will break the backward compatibility. Earlier code would not compile now. All those who implemented classes who implemented that interface, they would break. Fine. Fine. So in order to do such things, to allow you to add few methods, it says, okay, I'm introducing, I want a new method here, okay, but for old classes which did not implement this, I have an implementation, default implementation for them. Okay, that's where a default method was introduced here. Fine. Default methods. Fine. So what we have is a default methods. So if you want to write an implementation, declare it as default. If you don't declare default, by default it is abstract. In an interface, a method is abstract by default. So we have three kinds of methods now. Abstract methods, that's by default. We have static methods and we have default methods. When there will be issues with the multiple inheritance. Okay, there will be some issues with the multiple inheritance. Fine, because now, see, earlier, you know about the diamond problem related to multiple inheritance. Fine, what was the diamond problem? If you have a class A, right, and we had two other classes B and C which extend from A, and then trying to have a third type which inherits from both of them. Okay, type D here. What's the problem with D? Same method appearing here and same method appearing here. What should be available here? Right, that was the issue, and therefore we didn't have multiple inheritance of classes. And interfaces, multiple inheritance from interfaces were there because, see, the picture earlier was, fine. The picture earlier was something like this. When you define a class, Okay, you only have one superclass. Java is like this, and you have only interfaces, which can be multiple. There are multiple interfaces from where you inherit, right? So for this, from inheritance point of view, a implementation is inherited from only one source prior to Java 8. Now if you say I am implementing that interface, this interface also has default methods now where implementation is available. That gets inherited. So implementation is getting inherited. Okay, so what we also talk about is Java now has, see earlier Java only had multiple inheritance of types, only about types. This type has multiple super types. Okay, now we have multiple inheritance of behavior, methods, fine. Implementation of method, multiple sources are possible. And but we don't have multiple inheritance of state. State is only available in a class. State is not available in interface. No instance variables there. And so multiple inheritance of behavior but not of state. And that's what has been added. Okay, now so let's see how do we resolve the issue. Fine, in Java what happens when we have clashes, right? Same method implementation. So you have a method which is implemented in a class, you have a method which is also implemented in any of the interfaces. Okay, same method. What will be inherited by this class would be the one which is from the class. So the one from the class is having a preference over anything from the interfaces. Okay, fine. So there this doesn't give any error. But suppose, no, it's not in the class. Two interfaces have the same method, default. There are two interfaces having a default method, same method name. Fine. What will happen here? This would not compile. Okay, it would not compile. Now, that's fine, it doesn't compile. So what you should be doing? You should be overriding that method here. Okay, so let me take that we have method m1. Okay, maybe return type void. This is the one which is available in interface i1, and there's another interface called i2. Both have the method m1, and we are having a class C. Okay, there's a class C in which, now the class C which implements I1 and I2, right? Implements I1, I2. And we have class C implementing I1 and I2 both. Okay. So what happens? Now I must override M1, otherwise this will not compile. And you have to override the M1. So how do we override? So we'll say, okay, void M1. Okay. Now in this implementation, see one more thing, you recollect, even with classes, if I want to use a method, if I am overriding a method and I want to use the method which is implemented in the superclass, what do we use? Super.m1, right? We use super.m1. What we'll use here? I want to use the one which is in I1, or I want to use the one which is in I2. So I want to use the one which is in I1 maybe, because I think it's the I1s which is the one which I would like to use here. So it's available for you, and it will be available as I1.super.m1. or I2 dot super dot M1. Those default methods would be available for use in your classes like this. When M1 is default in I1, M1 is default in I2. When that same keyword super is used. But yeah, you have to prefix with the which interface.
And I cannot call super for both the interface methods, right? Because super can be used only once.
Oh, you might say, oh, I want to do both the things. I want to finish with M1 of I1, and so do that.
That is possible.
You can do I2 dot super dot M1 and then I1 dot super dot M1. The idea is those methods are available to you, both from both the places. From all interfaces which have method M1, all methods of those interfaces, default methods, you can use them. When interface name dot super dot method name, that default method name. Fine, so that's a way out for when we have multiple default methods from the interfaces, and it's not available in the super class. The implementation not there in the super class. Okay, in such a case, it would be like this. Fine. And so multiple inheritance by sub interfaces. Okay, even with sub interfaces, right? You have those default. So we understand when we have an interface, right? If there's an interface, it is inheriting from multiple interfaces. Fine. So there again, same issue will come. Your interface extends from interfaces, and yes, two interfaces from where it is extending has the same default method. Again, you'll have to override in such a case. And so that issue is there even with interfaces. Okay. Okay, now a new concept. Now let's move towards what we call as trying to understand functional programming from that point of view. Okay. So one is you have the concept of a functional interface. Okay. Definition of a functional interface. A very shortcut definition is they call it as SAM. Single abstract method. An interface with a single abstract method is known as a functional interface. Okay, but being more specific, and if we want to be more specific, okay, an interface with single abstract method ignoring any public methods of the object class. You don't consider them. Okay. For example, when we were looking at that comparator interface, and suppose we have that comparator interface. If you look at the comparator interface, the definition there, you will find there are two abstract methods. You will find two abstract methods. Okay, one is the compare method and other is the equals method. Equals method there is an abstract. Yes, you may have method of object class being an abstract class in some interface. Okay. So from the definition of saying, oh, single abstract method, this is not having single abstract method. But then you ignore any public abstract method of the object class. Suppose it was saying public abstract clone. No, that has to be counted. Clone is not a public method of the object class. So ignore only the public abstract methods of the object class and then say if it has a single abstract method. Functional interface. Right? So what is a functional interface? An interface with single abstract method. Fine. Ignoring any public methods of the object class. Okay, now functional interface, and another thing related to functional interface is the Lambda expression. Okay. Now, Lambda expression, functional interface, the idea of a functional interface is to allow you to have a type to represent a function. Represent functions. Look at a function. What is a function? A function is nothing but some kind of a box, right, which takes certain inputs and gives only one output. It can have multiple inputs, but returns a single value, or maybe return type might be void. It's not returning anything. Does some processing, right? That's a function, and it has input parameters. So input parameters separated by comma. Okay, and a implementation of this. In braces, I have the whole implementation of a function. That's a function. That's a Lambda expression. A Lambda expression is nothing but a function. Lambda expression is a function. This is actually a syntax of a Lambda expression. Okay, I'll give an example here. Okay. Int instead of, okay, let's say int a comma int b. Right? So a function which takes two integers as inputs, and this is what we call as a lambda operator, hyphen greater than, that's a lambda operator. And then we can write a whole implementation, multiple statements, full implementation. Whatever here you are writing as return, fine, you may have a return statement at the end here, fine, that's the return type of this function. So I have a function which takes these inputs, and that's how it is implemented. Whatever number of inputs you may have. Function has multiple inputs, right? So whatever, it may have 0 inputs, 1 input, 2 input, whatever. Fine, when you define a method, what do you put? It's a method. It's just a method, but without giving a name. Fine, not explicitly declaring, because I'm actually writing implementation. What we are doing with the lambda expression is we are writing an implementation of some method. Which method? That single abstract method of a functional interface is what is implemented by a lambda expression. Lambda expression is an implementation of the single abstract method of a functional interface. See one thing. So what is a functional interface then? Functional interface is a type. Think of it as a function type. That single abstract method is the function which it is trying to represent. Okay. If I say comparator, right? Everything else doesn't matter. What matters is only the compare method, how it is implemented. Right? See, I'll show an example now. I can say I have a comparator of, or comparator is generic. So I have a comparator of string, give a variable name. So length comparator equals, what is comparator? A functional interface. It's a functional interface, and therefore I can write a lambda for this. I can say what I am writing is a implementation of which method? Compare method, comparing strings. String s1 comma string s2, lambda operator, and then okay, I need to put braces, and I might be writing return s1 dot length, right, is s1 dot length minus s2 dot length. Fine, s1 dot length minus s2 dot length. That's my comparison logic. Okay, and this whole thing. So from here to here is nothing but an object of a comparator. But you are writing only a function. Fine. A function interface can be thought of as a function object. Fine. A type for function objects. This is my function. Clear? I need a semicolon here for the assignment. But this is my lambda. Now this lambda which I have written is, I have written with the full form. There are shortcuts in this. One thing is, from the context, when I am writing a lambda expression, from the context it is known that on the left hand side I have a comparator, and therefore this is a comparator. And it's a comparator of string, therefore I know this expression is a comparator of string. And in the comparator of string, the method would have a string as a parameter, and therefore I need not be mentioning string data type. I could have written this as s1 comma s2 and then written my implementation. And you can write your implementation. Another shortcut, okay, another shortcut would be, fine, it's not, so no, you don't have to put the types everywhere. Fine, for the parameters, input parameters, we don't need to specify types. Another shortcut is when you have an expression, fine, when you have only a single statement, what does it have? The implementation only one statement, you don't need the braces, and it's a return statement, you don't need the return statement, you just put the expression. So only this one, fine. No, I don't put the braces here. I'll just put s1 dot length minus s2 dot length. Fine. If you are implementing a method which has a return type of void, single statement, just put that statement.
If multiple statements, then we would use
Only in multiple statements, yes, you'll need the block. It's a block. Fine, we don't need the block when there is only a single statement. Fine. And if it's a return, don't use the keyword return, just the expression. Okay. Another thing was, suppose I'm implementing a interface which has only one parameter, single parameter. Then I don't even need the brackets. Okay, fine. I can just say some parameter. Let's say there's some method, some abstract method in a functional interface which says it takes int a as a parameter. I'll just say a and this. I don't need the bracket also. Fine. Those are some of the shortcuts which you have. Yeah, lot many examples available for functional interfaces. Comparator is one. You look at action listener, action performed, that's the only method. Fine. Action listener runnable, run method, callable of R, only call method, return type R. Okay, fine. So that way there are lot many examples of functional interfaces. So whatever existing interfaces which have only one abstract method, they are all functional interfaces. Okay, and so this is it's not about lambda is the next topic actually. Yeah, functional interface we understand now, right?
So when I used to functional interface in my class, I need to implement it now. I can directly use in my class.
Functional interface is interface like any other interface.
Implement last name and then implements, that's action performed.
Yes.
If I use this concept, I need to implement action performed.
You don't have to. You don't have to explicitly mention that you are implementing. Another big difference here is when we are writing a lambda expression. You know, someone might compare it with inner class, anonymous classes. You write anonymous class, but when you write an anonymous class, when you compile, at that time itself, the class file would be created.
Dollar and class.
Yeah, that so there is a class file which is created for it. Fine, at compile time. Okay, for your lambda expression, no such thing. Okay, it's dynamically the object is created at runtime, right, of a new type. It's a type for me, right? And use the symbol lambda rather than the whole spelling. Fine. So what is the lambda expression? Implementation of the single abstract method of a functional interface. And you only use it in the context of a functional interface. Lambda expression is not used otherwise. It's only used in the context of a functional interface. Okay. Fine. Parameter list, type 1 parameter 1, type 2 parameter 2, a lambda operator, and then the statements in braces. And three parts of a lambda expression. And input parameter list, the operator, and the implementation. Fine. The shortcuts. Fine. Okay. Another thing is about a method reference. It is possible only when implementation is a single method invocation. The implementation in a Lambda expression. So not all Lambda expressions may be written as a method reference. Okay, it's only for Lambda expressions that you may have a method reference, but not in all cases. Okay, only in case the implementation is about invoking only a single method. Okay, and that way, and the way it is happening is something like this, to be more generic. Okay, if I have a Lambda expression which is taking 3 parameters, I've just taken a general case where it might be taking a 3 parameters. So whatever n number of parameters may be there. Okay, fine. Now what you are doing on the first parameter of that input, you are invoking a method, right? A is the first parameter, dot method, and then the method is using the rest of the parameters. The idea is rest of the parameters. Invoking a method on the first parameter, fine, and the method's parameters are rest of the parameters of your Lambda. Okay, in this case, you may represent where, now what is this class name? The class name is nothing but the type for A. A is of a class. So you might use that class name colon colon, that's method. So it's class name colon colon method. Clear? That's one example. And we'll have more examples. Okay. Then again another case with 3 input parameters, but you might be using a static method. So you might have a static method. So some class, it's not related to this, right? So some class dot a static method, that's how you invoke a method, static method, class name dot static method name, and then you are having invocation passing all the parameters ABC to that static method, and this is nothing but 3 inputs, some class name dot, there is some static method, fine, I've just used the method name as a static method, and all the inputs to my Lambda are used by that method in that same sequence. Okay, then I have a shortcut for writing the whole thing by saying that class name colon colon the static method name. I need not say anything else. Okay, and the third form of a method reference, okay, is where you have your 3 parameters. Now on some object, you may have some object available, fine, for use in your Lambda. There is an instance variable, right, which is of type string, and string dot, maybe you are invoking a method on a string where the input to my Lambda, okay, so some object dot method, and I use all the inputs available to me by invoking a method on that object. Fine. Now we are not using class name, but we are using that object colon colon method. Okay. And so 3 cases where we can use a method reference. This is just method reference, I just call it so colon colon. They might have given operator for it. Yeah, correct. It must have been categorized as an operator, which is a constructor reference. So constructor reference is possible, fine, when we have a method creation, something like this. It is in general form. Say use 3 parameters, but whatever the number of parameters may be, right? The idea is to use all the parameters. Okay. So if you have new and some class and you are using all the parameters in the input, that's what you are returning. It's used only, it just says, okay, I create this return new something, right? Okay, where you use all the parameters for your Lambda. In that case, class name colon colon new. That's known as a constructor reference.